In this problem, we're asked to solve the following system by substitution. We're given a system of linear equations. The first one is y equals negative 6x plus 14, and the second one is 6 equals negative 5x plus 12. Now, what you should notice in these two equations that make up this system is that they are both in slope-intercept form. So I'm going to write that down. We have this as in slope-intercept form. When you have an equation that's in slope-intercept form, that's going to be y equals mx plus b. Now, the m in that equation is going to be representing our slope, and the slope is always going to be the change in y over the change in x. It's going to be representing a ratio. B is going to be our y-intercept. So both of these equations are already in slope-intercept form. Now, slope-intercept form, the y comes first, then you're going to have an equals, then you're going to have a term that's a variable term x containing an x with a coefficient, and then it's going to be plus b, which is telling you, if you were to graph this equation of this line, where this line is going to be crossing the y-axis. So in our first equation, we're told that y is equal to negative 6x plus 14, which I'm going to write here in red. The second equation, we're told that y is also equal to negative 5x plus 12. So as you can see in the first equation, y is equal to one algebraic expression, negative 6x plus 14, and then y is going to be equal to another algebraic expression in the second equation, negative 5x plus 12. Regardless of these two y's, the first y is going to be no different than the second y. So I can say that the red y is going to be the same as the blue y. Now, in our first equation, we're saying that y is equal to this algebraic expression. That means that y can be replaced with this algebraic expression, negative 6x plus 14, and no harm is going to be done here. So we're going to say negative 6x plus 14. And I'm going to replace that red y with its equivalent expression. Now, in the second one, the blue y here, it says that y is equal to negative 5x plus 12. So it means that this variable y can be replaced with this algebraic expression here to the right. So I'm going to replace that blue y with negative 5x plus 12. Now, the resulting equation is giving me an equation that has only one variable term in it, which is going to be the x. So if you look at this, we have a negative 6x here on the left, and we have a negative 5x here on the right. Now, what I want to do is I want to combine my variable terms on one side of my equals, and I want to put the constant terms, which are just these numbers, 14 and 12, together on the other side that's opposite of wherever I choose to place my variable term. So the first thing I want to work with is the variable term. So I have negative 6x, negative 5x. I always want to move, if they're on opposite sides, I always want to move the term that is the smaller of those two. So in this one, negative 6x is definitely smaller than the negative 5x, so I want to move that. I want to get rid of it. So I'm going to do an inverse operation. So negative 6x, the inverse of that's going to be adding, and I'm going to add 6x. Now, since I added 6x on the left-hand side of the equals, the additive property of equality says that I'm going to add 6x on the other side as well. So I'm going to add 6x over here, and I'm going to place it underneath that 5x, negative 5x, keeping everything kind of together here. Now, when I take a negative 6x and combine it with a positive 6x, those two things are going to cancel out, and it's going to equate to 0. The only thing I have remaining on the left-hand side of my equals is going to be the number 14. So I'm going to write that down, 14, still have that equal sign. Now, when I take a negative 5x and combine it with a positive 6x, that is going to give me either 1x or just plain x. And I still have this plus 12. Now, what you'll see is that I took my negative 6x, my negative 5x, I combined those two terms, and I now have them consolidated on the right-hand side of my equals. Now what I need to do is I need to get all my constant terms on the opposite side of that variable term x. So I need to get this positive 12 over to the other side. Now, since it's a positive 12, in order to move it, I need to do an inverse operation of subtraction of 12. So I subtract 12 on the right of the equal sign, and what I do on the right-hand side of the equal sign, I must do on the left as well. So I'm going to subtract 12 over here. Now, when I take 14 minus 12, that's going to give me a 2. And then that's going to be equal to x. The positive 12, the negative 12, those two things are going to cancel each other out, and it's going to give me a 0. So what I've found here is that the variable term x, or the variable x, is actually going to be equal to 2 in this particular problem. Now, what I need to do is I now need to find out what y is. Now, I know that y is equal to negative 6x plus 14, and I know that y is equal to negative 5x plus 12. All I need to do in order to find out what y is replace one of these x's in either one of these equations with 2, and then that will allow me to solve for y. So I have a choice here. I can either use the top equation or I can use the bottom equation. Looking at these two equations, I have a negative 6 and negative 5. So I'm going to use... I'm kind of leaning towards this equation now because I just have a smaller number to deal with, negative 5. Looking at the constant terms, that's going to give me a little bit more of an indication. So I have a larger number here with 14, smaller number here with 12. So I'm definitely going to use that second equation there. So I'm going to start off with the equation saying y equals negative 5x plus 12. What I'm going to do is I'm going to let x equal what I found it to be down here, which is going to be 2. Now, from here, I'm going to replace this x in this equation with 2. So that's going to give me y equals negative 5 times 2 plus 12. From here, I'm going to take and combine and the negative 5 and the 2 through multiplication. So I'm going to say y equals negative 5 times 2, which is negative 10, plus 12. And then y is going to be equal to the combination of these two. When I take a negative 10 plus 12, that's going to give me a positive 2. So my solution to this system of equations that I actually solved through substitution is going to be in an xy format. So I put it in parentheses with x and y. I'm going to place my x first, which should be 2, and then the y, which also should be 2. So my solution to this system of equations that I solved through substitution should be 2, 2.